Howdy, we're the Interactive Kinematics exhibit team, and my name is Riley Pruett. Our team consists of 5 other mechanical engineering seniors: Anthony Lee, Clayton Maywald, Caleb Johnson, Luis Rodriguez, and Pepito Thelly. Let's just jump straight in. The users of our project are going to be kids ages 8 to 12, so we decided to put a fun little dramatized twist into the introduction to our project. Let's take a look at that now.
So dark in here, I can barely see a thing.
I know, I can't even see what we're doing.
Does anyone have a flashlight?
All we have is my bicycle and these light bulbs and these wires I found.
Imagine if we could light those light bulbs up.
Wait, don't we also have that generator?
Yeah, but it's not like it's glow in the dark. It's useless to us.
Guys, hear me out. What if we could use these light bulbs, stick them to our hands, and power some stuff? Wouldn't that be cool?
Wait, you might be onto something.
Wait, seriously? I was joking.
Yeah, what if we could use the energy provided by our bodies to power light bulbs and stuff? That would be really cool.
That'd be crazy.
Wait, that's the conservation energy stuff, isn't it?
Yeah, it is. It's a bicycle is an instrument to convert human energy into mechanical.
Yeah, but how does that help us? We didn't convert electrical energy into power light bulbs.
Well, that's what generators do. It uses a magnet and a coil to create electrical energy from mechanical energy. It uses something called electromagnetic induction.
Wait, guys. We're a group of 6 mechanical engineers. How do you know all that? That's electrical stuff.
Well, our curriculum is set up in such a way that we learn a lot of other things in other disciplines.
That's actually very neat. We could hook up the bicycle to the generator to power those light bulbs.
Yeah, I mean, that would be such a cool and interactive way to teach kids 8 to 12 years old at the Boys and Girls Club of Brazos Valley physics and engineering concepts.
And we can call it the Electro-Cycle.
As you saw from our introduction, our senior capstone project, the Electro-Cycle, is an interactive exhibit which showcases the conversion between human and mechanical energy to electrical energy. We are a team sponsored by the Boys and Girls Club who have given us this opportunity to put our engineering skills to construct this exhibit in a fun way to learn physics and engineering for students aged 8 through 12 as part of their STEAM initiative.
STEAM stands for Science, Technology, Engineering, Art, and Math. The mission of the Boys and Girls Club is to enable all young people, especially those who need them the most, to realize their full potential as responsible, productive, and caring citizens. From our personal experiences, we believe that education is a pathway for all people, no matter the age, to realize their dreams and potential.
As such, we are extremely excited to have been able to apply our curriculum engineering knowledge to construct this exhibit for the Boys and Girls Club of Brazos Valley. Now, how do we do this, you ask? Well, let's go to Anthony to find out more.
So this is our exhibit. We have several components built into the exhibit. We have a lights component, battery component, and then we have educational videos which will play on this tablet here. So up here we have the light box. We have 2 types of light bulbs. We have halogen light bulbs and then LED light bulbs. The purpose or the reason why we picked 2 different types of light bulbs is to show how each one reacts, right? In the exhibit you're going to see that each light bulb requires different power inputs to light, and then you'll be able to see the efficiency of the light bulbs as well. So how does this work? We have this panel here that controls basically everything on this exhibit. Starting with the big switch, we can change it from lights to battery. Right now it's on off. When I turn it to the left on the first setting, it's going to power the lights. Over here we have the smaller switch which controls which light bulbs get powered. We have LEDs and halogen. For LEDs, switch them to the bottom and go ahead and pedal. The lights go on. If I switch it to halogen, which is the top position, halogens get light on. To get to the battery components, turn the switch all the way to the right on the second setting, which will then turn on the battery. Kids will now pedal on the bike, which then powers the battery. And then we have battery chargers here for students to charge their AA batteries. Now back to you, Pepito.
Thank you, Anthony. As you probably saw, this exhibit consists of both mechanical and electrical subsystems. Let's first take a look at some of the mechanical aspects of this project.
Thank you, Pepito. Now let's look at this from a mechanical standpoint. We built the frame using 2x4 plywood overlay, and we also have static structural support so that it's built to last. Now let's take a look at the bike itself. We took off the front wheel and we also took off the brakes, and we attached it to a wooden support that we built ourselves. Now let's take a look at the back wheel. The back wheel is connected using a rear bike mount. The back wheel is connected to the generator via a belt. The tension in the belt and the angle at which the belt connects to the generator, as you can see right here, is crucial for maintaining maximum efficiency. Because the belts will loosen over time, we decided to go with the notched V-belt that the Boys and Girls Club can adjust following our manual that we're going to send to them. As you can see, there is a box around the rear wheel and the generator. The framing of the box is made out of wood while we use plexiglass. This is so that the kids cannot touch any of the components inside and hurt themselves. We also made sure that we use clear plexiglass so that the kids can still see what's going on inside. As you can see, there are holes at the top of our light display. This is to improve heat dissipation. We also have an acrylic tinted safety glass. This is so that the kids do not become blinded as they are generating the electricity.
Now, as Caleb mentioned, the bicycle is connected to a generator. This generator in turn generates the electricity used for this exhibit. The electricity follows various pathways once generated. Let's take a deeper look at some of these pathways.
Thanks, Pepito. These two wires right here are generator leads. This is a 15 amp circuit breaker used to safeguard and protect our circuits in case of surges. These two terminals right here take the input from the generator and split it multiple ways. The main way is to our main switch. This is where our pathways converge. This is the main switch that switches between the lights and the battery system. The second switch switches between the halogen and the LED bulbs. As you can see, here we have the rear of our 6 LED bulbs. These terminals are used to connect the bulbs in parallel, one being the positive, one being the negative. The same thing was employed for the halogen bulbs, which are all ran in parallel using these two terminals as well. The second output of our main switch is the battery system. In the battery system, we have a sampler. The sampler is used to check the battery's percentage as well as the voltage and the incoming current. Furthermore, we have another set of terminals which are used are our extended battery terminals. This is the positive side, this is the negative.
Alright, now that we have an understanding of how the entire system works, let's take a look at some of the finer details of this project. These fine details are what transforms this project into a product that we're going to present to the Boys and Girls Club. For ease of use, we have provided the Boys and Girls Club with a user manual and easy-to-use maintenance guide, which will then ensure that the exhibit remains in tip-top shape throughout its entire lifetime at the club. Now, the engineering is all well and good. We designed, we analyzed, we constructed, and we verified. But how do we translate this into value for the sponsors? Well, our sponsors are looking for something that will educate future generations. To act as a supplement to our exhibit, we are providing various educational videos covering anything from mechanical and electrical systems to the engineering design process. Using cutting-edge lightboard technology, we made these videos fun, interactive, relatable, and easy to understand. Why don't we listen in to Luis and Caleb explaining what resistance is?
Now let's talk about resistance.
Nah, I got this. In electric world, resistance is like a roadblock for electrons. As you can see, I can just draw an arrow that represents the flow of electricity just straight down, but if we have resistance, see how much harder it is? How much longer it takes for the flow to get there? It slows them down. Thales might have discovered static electricity, but in our circuits, resistance is what controls the flow of electrons. It is the traffic stop of the electrical world.
As this project comes to an end, we would like to extend our gratitude towards Miss Rhonda Watson, Miss Fatima Bergwino, and Miss Valencia of the Boys and Girls Club for giving us this opportunity and offering relentless support and encouragement. We would also like to thank our faculty sponsor, Dr. Ravi Theagaragan, for continued mentorship and guidance. Additionally, we would like to thank our Capstone instructors, Dr. Sen, Dr. McFarland, and Dr. Balawi, for ensuring that our creativity was driven to an end product. With that, we hope you enjoyed our video detailing the Electro-Cycle, an interactive kinematics exhibit sponsored by the Boys and Girls Club of the Brazos Valley.
You serious? I'm just joking.